Hi everyone! I have with me what you should have right now, which is a blank fortune teller, or a chatterbox, as some people call it. We're going to use this to review for Newton's first, second, and third law. So this is my completed one here. I'm going to show you what you want to have on the top, on the outside. And in order to make this, we're going to need to flatten out our little fortune teller like that. On the first side of your fortune teller, you're going to want to write Newton's third law here and force pairs on the other side. So just like this. And then on the back side, if you flip it over, you are going to write Newton's first law and Newton's second law. Alright, so now that you've made the outside of your fortune teller, I'm going to show you how to make the inside. So when you open it up, so first it looks like this, and then when you open it up, we want to be able to see our options. In order to test yourself so you're ready for the celebration of learning, we're going to start with Newton's first law. We're going to review the definition and then give an example. So when you open up the red, you didn't have to color this fortune teller. I colored it because it helps me to think of different colors to keep it organized. But I have a red tab for Newton's first law. I'm going to lift up my tab, and on that tab, I'm going to write definition first and example first. And then if you go to Newton's second law, your Newton's second law tab here, I'd like you to do the same thing. Example second. And see if I can get it so you can see it. The definition of the second law, right there. Okay. Finally, you have your Newton's third law tab. Flip it over. You're going to write definition of the third law, an example of the third law. And last but not least, on your force pairs tab here, you're going to flip it over, and this one's a little different. Okay, so this one has draw a force pair. Draw a force pair. Okay, this is testing you if you know how to draw a force pair. I drew an apple and a carrot. So you need to pick two objects. You can pick an apple and a carrot, or you can be different. They need to be touching. And then on this side, write how are force pairs different than balanced forces. Let me see if I can get it so you can see that. How are force pairs different than balanced forces? Good question for you to think about. Okay, now let's focus on the force pairs question. We'll open it up. So when you're giving your fortune, you open it up like this. And right here, I really like pictures, so I drew pictures of mine. I have the apple and the carrot example. Okay, I drew them touching. Notice that I have two arrows, 1, 2. I have F carrot and F apple. You need to have the labels as well as the arrows touching where the objects are touching. And the arrows need to be the same size. Okay, next thing. The answer to the original question is a balanced force has to do with one object, and force pairs always have two objects. So that's how you kind of want your force pairs tab to look like. That's what you want to be testing yourself on there. And let's go ahead and move to Newton's first law. I colored my Newton's first law red. The definition of Newton's first law is an object that is moving likes to stay moving. An object that is still likes to stay still, unless these objects are acted on by an outside force. And an example of this, if I shoot a bullet, a gun, into space, I'm going to get back so you can see me. Maybe it's not as weird as seeing my mouth move. I wrote here my example. A bullet moving in space, if it's shot out of a gun, will never stop moving because there's no force of gravity to act on it. Okay, you are halfway there, more than halfway there. We have the second law now. A lot of you have done a really good job with the second law. The second law is an equation that talks about the relationship between force, mass, and acceleration. Force is equal to mass times acceleration. If an object, you flatten out so you can see it. If an object has more mass, it will take more force to accelerate it. In my favorite example, a tiny pumpkin is easier to roll, to accelerate, than a giant pumpkin. And then we have our last law, the one we've been studying right now. This is Newton's third law. So this law says if two objects touch, they push on each other with the same amount of force no matter what their mass. And we know that if a tennis ball hits a car, it pushes on the car with the same amount of force that the car pushes on the tennis ball. If the car hit a bowling ball, the bowling ball would still hit the car with the same amount of force that the tennis ball hit the bowling ball with, even though the bowling ball has more mass. So here's this one. And now, when you're folding it back up, you want to start by folding in all your corners so it looks like this. And then you want to fold it back over so it looks like this. And I'm going to put my fingers in my fortune teller. It's a little tricky sometimes when you're getting it to fold back together after you've been writing on it. You might need to help it out a little bit. But it should look like that. Have fun studying.